Polynomial long division follows more or less the same pattern in every scenario, but we do have a couple of other ideas that we need to look out for. The polynomials that we're using to divide need to be written in descending order based off their degree, and we also need every subsequent term represented. So x squared would actually need to be represented as x squared plus 0x plus 0, so that we have all of those descending terms represented. That means in this case we'll be taking x squared plus 0x plus 0 and dividing that into 3x cubed minus 9x squared plus x and plus 4. Our process starts the same, except that now, since we have three terms we're dividing by, we need to look at dividing into the first three terms. And here we'll multiply by 3x in order to get x squared to become 3x cubed. Multiplying by 0x will give us plus 0x squared, and multiplying by 0 will give us 0x. Then subtracting those two rows will give us negative 9x squared plus x, and then dropping down that next term, plus 4. Next we'll multiply through by negative 9 to make that leading term negative 9x squared plus 0x plus 0. And then again subtracting those two rows will leave us with x plus 4. So in this case our result is 3x minus 9 with a remainder of x plus 4. Which again we could also rewrite as 3x minus 9 plus the quantity x plus 4 divided by x squared, which is what we were dividing by. In example 3, we'll need to revisit that idea of rewriting a polynomial function. In this case, it will be the polynomial we'll be dividing into. We need to reorder the terms so that our polynomial is listed in descending order, and we'll need to introduce placeholder terms for the missing powers of x to get x to the fourth plus 0x cubed minus x squared plus 0x and plus 7. So in this case we'll be taking x squared plus x plus 2 and dividing into that now rewritten polynomial function. We have three terms we're dividing by, so we'll look at dividing into those first three terms. And we'll start off by multiplying by x squared to get x to the fourth plus x cubed plus 2x squared. And then subtracting will leave us with negative x cubed minus 3x squared, and then we'll drop down that 0x term. Next we'll multiply by negative x, which will give us negative x cubed minus x squared minus 2x. And then subtracting will leave us with negative 2x squared plus 2x, and then we'll drop down that last term to get plus 7. Our last step will be to multiply by negative 2, giving us negative 2x squared minus 2x minus 4, which will leave us with 4x plus 11 once we subtract those two rows. So the result of our long division in this case will be x squared minus x minus 2 with that remainder of 4x plus 11. or x squared minus x minus 2 plus the quantity 4x plus 11 all over x squared plus x plus 2. Again, in these two examples, the process was very similar, but we do need to start by investigating each of our polynomial functions to make sure they're written in decreasing order, and if necessary, to be sure that we've inserted these placeholder terms for any missing powers of x.